So welcome, good afternoon. This is our session on the R-ArcGIS bridge. My name is Margine Pabuda, and I am a product engineer for the spatial statistics team here at Esri. I probably started working on the bridge maybe about a year and a half ago, back when it was just kind of a ragtag team of a couple people in their spare time that just thought that this would be awesome functionality to have. And it's greatly grown over the course of the past year and a half to become something that we've seen just a ton more clients and users looking to add into their workflows. And we're really excited to kind of update you on what's new. And so we're going to dive into that in just a second, but first, to introduce my co-presenter.
Thank you, Margine. Hello. My name is Oren. I'm part of the spatial statistics team too, and I've been on the R project for the past couple of months. And I'm excited to share some of the new functionality with all of you.
Awesome. So today's workshop is entirely focused on what's new. We're going to briefly start by diving into some of the basic functionality for those of you that are maybe new or unfamiliar with the bridge, just so you get a taste for what it was designed to do and what you can use it for. But we really want to try to spend as much of this presentation as we can on the new additions, which of course would be raster support. We have long been asked for the ability to support raster data, and we are very pleased to announce that that now is a reality and to show off what it can do. And to also kind of talk about some of our solutions for big data with the bridge, because of course that's a big part of working with R. If you're working in memory, how are you going to handle big data if R is what you want to use? So the slide that I have up right now, after this presentation, at the end of this week, we're going to be putting up all of our presentation materials under the spatial statistics resource page for presentations. So if you're interested for these, please look here. If not, come see us afterwards. We're happy to give you a card. You're always welcome to reach out to us if there's anything specific that you're looking for that you need immediately, or just you want to ask us some questions. So that's an option for you as well. To dive in, let's start with some of that basic, what is the bridge? What is the R-ArcGIS bridge? Why should you be interested in it, etc.? And that really kind of starts off with the question of why R? Now, maybe some of you already work with R and you love it, and I don't need to preach to you the wonders of R. But maybe you don't, and maybe you're wondering, okay, there's Python, there's R, how do I pick and choose what it is that I use? When it comes to why R versus Python, here is what I would say. R was a language designed for statistics. Python is a general language. If you're looking for cutting-edge research methods, R is really the place where it's happening. A lot of people in academia or performing research in their field are producing their work in R packages, and it's where you can go to find a lot of those cutting-edge, novel methods. Additionally, R is also, since it was designed for statistical analysis, a lot of the objects in R are oriented with that in mind. So a lot of the structures are built to make it easier to do various types of analysis. So while you might be able to reproduce functionality in Python, it's often a little more intuitive and simpler, less lines of code in R. Now that's if you're looking to do your cutting edge statistical methods. Now if you're looking for more large scale automation, or if you need that general language structure, then yes, Python is maybe the direction you want to go. So it really just depends what you're looking for and what you're seeking to achieve. Now, of course, R is continuing to grow. There's over 12,000 packages available on CRAN right now. It's quite versatile and powerful, and one of the reasons why we've bridged to it is because it might provide the solutions you need for the problems that you're trying to solve. So it's just one option you have. Now, a little bit more about kind of R as a language, and what I was talking about referring to the fact that it was built with data analysis in mind, R has derived from the language S, and S was quite novel in the sense where it kind of started by introducing this concept of a data frame in code, essentially a way of storing your data in a table that's easy to access, to manipulate, to aggregate, to perform various analyses on. And R has kind of taken that from S, improved upon it, and it's one of the reasons why R is so efficient at performing various types of analysis. Now, of course, Python and Pandas has also taken from R this concept, so there's other places that this does exist, but R was kind of the first main place where this data frame concept came to be, and it's one of the reasons why R is so good at what it does. Now, why R from an Esri perspective? In addition to just having data frames that are non-spatial, R also has packages that support spatial data. Most common are SP and now SF. And essentially, these packages not only have a data frame-like structure for keeping your attributes, but it also has a spatial component. So all of that important information about your data regarding its projections, any type of spatial attributes it has, are stored. And so there's a lot of different ways you can work with spatial data in R, whether you have your vector data, points, lines, polygons, or if you're working with rasters. So this is one of the reasons why we felt that R was a powerful language to have an integration with. Now, what exactly is the bridge? We created the bridge because essentially when it comes to solving a lot of the complicated problems that we face in the world today, you often need the best available tools. And there's rarely one platform that's going to do it all. I mean, we all wish that was the case. It'd make our work so much simpler if we didn't have to learn all these different things. But the fact of the matter is we often need to pull from different places to get the right tools to do the job that we need to do. And so a key part of branching out to R was the fact that it would provide access to cutting-edge methods that might not have made it into our platform yet, as well as field-specific analyses. If you're working in a very particular area, you might have certain niche methods that are very specific to you and your organization, in which case there's a good chance that R might have access to them. So that was one of the reasons of why we wanted to create this bridge, to give people access to that, and to perform an integration that is really done well. If you've ever tried to transfer data between multiple platforms that don't work well together, you know you can lose countless hours with something as simple as just getting your data in. That's incredibly frustrating. So this is meant to make it easier. Now, who might be using the bridge? It might be just you. You might have a very specific reason that you want to bring your data to R, a very specific method you want to use. Great. We have provided support for you to do that. You might also want to share this functionality. You might be going to R to perform a method, but you don't want to have to be the only person in your organization that does that. You don't want to keep having people come to you saying, hey, can you do this again? Hey, can you do this again? Can you do this again? It'd be great if you could just provide people with a tool that could do that, and then they could do it on their own. And so that's another reason why we built the bridge, so you could share this functionality. We also created the bridge to help those that just wanted to work with R. We know that RGDAL exists, but the bridge, the package behind the bridge, the ArcGIS binding package, kind of meant to go a step further and improve upon RGDAL. So let's talk just a touch on that. When it comes to bringing spatial data into R, we try to improve upon that process. And so a common question we might get is why the bridge versus RGDAL? Well, it kind of depends what you're doing. If you're working with shapefiles, you're probably going to find that the functionality is equivalent. If you're looking to do more, if you're working with file geodatabases, you're looking to not only read but write, the bridge is meant to make that process easier. The bridge also provides a lot of functionality for manipulating that's just built into our function calls. So if you're bringing your data in and you want to be making a selection, you want to be reprojecting, you want to be doing things with like, for rasters, if you're bringing in certain bands or you want to be resampling, all of that functionality is built into our one line call of converting that data. So we tried to simplify that process. So it helps to make things easier, faster, and really any data type that you can work with in ArcGIS, the bridge will allow you to bring in. So that doesn't just include shape files and file geodatabases. That can also talk about things like hosted feature layers, that can be URLs for an image service. Really anything that you can view in Pro or ArcMap, the bridge will allow you to bring in with the same line commands. So it improves upon that process of accessing spatial data. What do you need for the bridge? Just in case you're like, yes, let's do it. ArcPro or ArcMap, either or, is perfectly fine. For ArcPro, 1.1 or later is what you'll need. For ArcMap, 10.31 or later. For R, we support back to R 2.2 or 3.2.2, and RStudio, it's optional. It's just a nice IDE if you prefer to work with that. When it comes to installing the bridge, we've made this process easier when you're working with Pro now. We've essentially integrated support for installing the bridge right into Pro itself, and this is something that I will show off in just a little bit here. If you are still installing with ArcMap, no big deal. You just have one more step to do, and I'll show you where you can find resources on that. But when it comes to getting started with the bridge, it's pretty simple. There's really two lines that you need to worry about. The first one is simply, where is your data stored? And that's using ArcOpen. That's our function for indicating where that data location is. And you see here, my example is a shape file, but this is where if you have a URL, it's that URL. This is where, if it's in a geodatabase, it's that location of the file geodatabase on your computer. And from here, you can use ArcSelect to bring that data in. And here's kind of that powerhouse function, if you will. This is where you're making your selections based on if you want a subset of columns, if you want to craft an SQL query to bring in a selection of rows. This is where you can adjust that spatial references. This is all stuff that I will show you right now. I often find when it comes to the bridge, it's just easier to see it. So let's kind of take a dive in to some of this basic functionality. To begin with, if you have Pro, installing the bridge can be done right from within your project tab here. You can click on your project tab. Under options pertaining to geoprocessing, we have built-in support for the bridge. You can select your desired version of R. As you can see, you can have multiple versions on your machine. Any version, 3.2.2 or greater, is perfectly fine. If you've never installed the bridge before, your first option here will be to download and install from the internet. I obviously have it installed because I'm going to be demonstrating some things, but it's nice. In Pro, it's all integrated in-house. If you're looking to do this in ArcMap, not a big deal. There's just kind of one more step. And we have resources for this on our GeoNet page. We have a bunch of videos on how to do it. So if you're like, help, it's all here. Same thing, if you just go to our GitHub page and you kind of just click on our first thing about the bridge, you'll find a whole list of resources as well. Installation is one of the first topics. So just an FYI if you're looking to install. The first use case of the bridge is really just kind of that simple, you want to get your data into R. It's you alone, you want to bring your data in. At any point in your analysis, you can open up R, and once that bridge is installed, you simply load the library for the bridge. This ArcCheck product will just establish that that connection between R and ArcGIS is up and running, and then you can use your commands to bring in that data. So ArcOpen, ArcSelect. ArcOpen, as you can see, it's just my path for where my data is stored. In this case, it's a file geodatabase here. And then ArcSelect is where I'm actually going to be doing a little bit more. ArcSelect normally just converts my data So it's changing it from an ArcGIS data type into an R object. But you can kind of see here that I've added some things. I'm doing an SQL query. I'm only interested in these particular observations. These are buffalo types, so it's the queen buffalo. That's who I'm interested in. I'm also doing a reprojection here. I'm adjusting my spatial reference. This part is really quite nice because what I can do is I can go online and I can say, hey, what is the spatial reference that I want? I can get my number, and then I can pop back in, put it, and the bridge will take care of that for me. If we check here for my original data, you can see my original spatial reference here, and if we check in for what I've reprojected, we can see just like that, it's changed, which is quite nice. Now, what I have here essentially is a data frame object. That means that any functionality that requires a data frame I can tap into, which is awesome. Or if you want to be working with spatial data, we have functions for bringing it into SP and now new SF. So you can see here we have two functions to take that data frame and to convert it to either an SP data frame, spatial points data frame in this case, or SF. SF is kind of new. It's newer than SP. It's meant to simplify some of the complications of converting between different types of spatial objects in R. Just something of note that we've added in. And right here, as you can see, this is where it's up to you. Whatever you want to tap into, you can do that. And of course, I can, after I've done any of my functionality, I can write back to ArcGIS. And if I go here and just refresh, I have my subset that I've made of my buffalo. And it's also got a new projection. So that's why it's like, whoa, where's that? Now, the other cool thing to make a note of here is that this is just like bare bones basic functionality. The bridge can do a lot more. What you've just seen is kind of what you would do if it's just you and you want to bring data into R. Great. The bridge can actually be used to share all of this, and a really good way to demonstrate that is just with a little bit of a teaser of a script tool. This is a script tool that's calling out to R, and you can see I've made a selection here in my data. And the nice thing about this integration is it's fully integrated. This tool is calling out to R to perform clustering, and it's actually going to be honoring this selection that I've made, which is really kind of nice. So this is where we're starting to dive into that next step, that next level, where maybe you actually want to use the bridge to share functionality with somebody else. And if that's the case, the bridge is great for doing that as well, either by having your script tool or, as we'll look at in just a second, by integrating in other ways. So you can kind of see here, it's honored that selection, it's performed clustering on that one area. It's kind of sweet. Okay, that was like dive in quick and dirty into functionality that's already existed for quite some time in the bridge. What is new is going to be raster support. So when it came to raster support, we knew that this had been something people had been asking for a long time. So we really wanted to make sure that we did it right and that we did it well. So right now, you'll find online a new ArcGIS binding package that includes raster support. Any ArcGIS supported raster data type is supported by the bridge. So that means, of course, anything with mosaics or CRF formats or any other raster data type you might be using, it's all good. We tried to also pack in a ton of manipulation functionality. So when you're bringing in those rasters, you have the ability to make selections by pixels, rows, columns. You have abilities to make selections by bands. If you're making a selection, you can resample, and we have different resampling options built into our bridge functionality. You can, of course, still adjust that spatial reference. Those are all things that we've put in. And you've kind of already seen just a taste. We've also, with this new release, supported the SF package. We've also made sure that now if you're working with Dplyr for doing aggregations, that we maintain your spatial geometries. So if you're adjusting, you're filtering, you're doing different things to aggregate your data, those spatial properties are still being held. And we've also included ArcDelete. It might seem like, oh, but if you ever write something and you're like, hey, I want to get rid of you, we've added a function to do that as well. So how does this look? How is it different? So you kind of saw already ArcOpen, ArcSelect. So what if you're working with raster data? What do? It starts off very similar. ArcOpen, just indicating the location that raster is at. And then it goes into a new function, ArcRaster. And ArcRaster is where it's going to do that conversion. So if you have a single band raster, it's going into R as a raster layer from the R package raster. If you have a multi-band raster, it's going into R as a raster brick from the R package raster. And of course, here's just some of that built-in functionality if you want to be manipulating as you're bringing it in. Now, when it also comes to raster data, once you've converted it into that ArcRaster, this is where you have one more step. You can just do as raster to transform it into that raster object, or as whatever it may be, maybe a spatial pixel, spatial grid, whatever you need it to do. So let's kind of dive back in to a peek at this. In my package here, what I was initially working with, even though I didn't really introduce it, was buffalo locations. So the data that I have here is a sample of buffalo that are located in South Africa. They're actually quite fascinating to study. They have a lot of important ecological and economical impact here in South Africa. These buffalo happen to be part of the big 5 game animals in Africa, so they're quite important for tourism. They also are a key part of the ecological sphere there. And what this analysis was originally designed for was to establish a new conservation region based on these buffalo. And a lot goes into this. There's actually a method in R known as an ecological niche factor analysis. It's a very specialized analysis that essentially takes presence data only. So in this case, the locations my buffalo are present, and it learns about various environmental conditions that they're living in. And so this is where from ArcGIS I can access a ton of raster layers regarding the environment and climate to essentially paint this portrait of what the buffalo prefer ecologically. And I can pass all of that information into R to perform this analysis. Now, with the bridge's new support of raster data, the first thing that you obviously want to check is that you are working with the latest package. You can see here that my package is 229. If you're looking to work with raster data, you want to make sure you have the same. And if you go onto our bridge page here and you look at our latest version of the bridge, you'll find that that is the latest version. So if you've already installed the bridge, you'll just want to make sure you update, and you can do that inside Pro, or if you're working with ArcMap, you can just also update there as well. Now, the nice thing about this integration that we have with the bridge is that if I've found an analysis in R that I want to take advantage of, and preferably one that I want to make available to others, I can create a tool that is calling out to R to perform this functionality. Now, while this tool might look like any other tool, it's not. This tool is quite special, because if I were to go to its properties here, you'll see that it is referencing an R script. And you'll also see here, with the support of raster data, of course, my input can be rasters, my output can be rasters. You can now have tools that integrate both vector and raster data, which is quite powerful. And the other really nice thing here too is you can create these models that integrate both ArcGIS and R. For this particular analysis, I actually had a lot that I needed to use spatial analyst tools for. A lot of these rasters that I'm working with are categorical, and when I'm using my ENFA analysis, I can't have them as categorical data. I need to perform a common workflow where I'm adjusting them to quantitative values. And that was something I was able to accomplish here with Con and with focal statistics. I was able to essentially kind of reclassify my data before passing it into R. So the beauty of this is with this integration, this model seamlessly works. And what it's doing under the hood is it's referencing a script that I've created, a script tool. And this script tool is taking advantage of that new raster functionality to bring in these rasters and to perform this ecological niche factor analysis. And you can kind of see my charts are popping up from my analysis run here. But the nice thing with the bridge, too, is that, as you can see, we can kind of dive into the help for this package. And you can see here, even though I'm not taking a ton of advantage of it right here for this particular analysis, I have that ability to take advantage of all that custom manipulation by bringing in bands or adjusting things with my extent, resampling, etc. But with these tools, I can obviously tap into any package here in R, and I can have those results either appear on my map or integrating our charts. It's just like a really nice ebb and flow of the functionality here, which is awesome. And the new thing, too, that's cool with ArcGIS Pro is when you create these models, you obviously can share tools. You can share your script tools, but you can also share your models as well. If we take a look here at my project, I have my script tool, which I could share, but this whole model that's integrating ArcGIS and R, I can actually share this as well. Whenever I've run this model, it appears in my history here. And while you may be familiar with the fact that you can share it as a GP service, you can also share it as what's known as a web tool, which is going to enable you to provide all of this functionality to somebody using ArcGIS Online, which is quite nifty. So here I have just kind of the basic configuration for getting a web tool up and running. And it's nice because kind of like a script tool, you have complete control over what is exposed to somebody. So somebody can have complete access to this entire workflow, every piece from ArcGIS to R, and they can ultimately have access to it online, which is really kind of cool as well. It's just a way of sharing all those pieces. So kind of what we're looking at here is that basic functionality that's spanning from just you on your own, transferring data back and forth, whether that be vectors or rasters, to kind of more advanced functionality where maybe you're integrating it into ArcGIS via a script tool, or maybe you're going one step further and you're integrating it into a model. Kind of just like nice things. Now, the final piece that I'm kind of going to close with is that all of this functionality is great, and it's really fantastic getting access to all of these cool R packages to perform various methods that might not exist to me in ArcGIS. But as you maybe know, R can sometimes be a little bit fickle. If I were to actually run this exact same workflow in 32-bit R, meaning, of course, I'm working with ArcMap, I'm actually going to run out of memory, which is sad. So luckily, we've provided some solutions to help with that. So I'm going to pass it over, and we're going to dive into kind of how you can handle big data with the bridge.
Thank you, Margine. So as Margine mentioned, sometimes we can run into data memory limitations or computational limitations, especially if we're working on big workflows. So today I'm going to talk about another dimension of our integration with ArcGIS Pro and R, our integration with Microsoft version of R, or MRAN, as they call it. That enables you to solve your problems on a bigger data set, and it gives you access to many of Microsoft's enterprise tools where you can really scale up your R scripts on a server. And in general, there are certain portions of the base R functionality that they re-implemented. Now you can have speed ups up to 500 times given your 5,000 times given your the size of your data set and the type of operations that you're doing. So I'm just going to briefly talk about this dimension of our integration with Microsoft R. So you have seen many of the demos that Margine has shown you. What is different in terms of integration? Actually, nothing is different. Everything is exactly the same. but I'm just going to demo some of the new functionality that you can tap into using Microsoft R. So how is it different? Well, the logo is a little different. It's a little more friendly. It's publicly available, so you can download Microsoft Open, and it's free of charge. And it implements all the pre-existing functionality in R. Actually, just to show you where to go, here is their page where you can just get your version. Works exactly like R, and if you like using RStudio, you can just link to this version of R. It really is not different than having two different versions of R in your machine. So you can have a Microsoft R and a CRAN R. And our integration with it is seamless. You can't even tell the difference what is in the background. So our connection to the ArcGIS binding package for the MRAN or the Microsoft version of R is exactly the same. As a matter of fact, just like you would do for a regular R version, you can just go to Options and Geoprocessing. And here, ArcGIS Pro is going to look at which versions of R you have. I generally have multiple versions of R on my machine because I do different stuff with different versions. So I have the Microsoft R, and I have R server. And integration is very easy. If I want to integrate ArcGIS binding package to my Microsoft version of R, I just select that version, and then I integrate it, just like I did before. So it's exactly the same experience for you. So as I said, there are different flavors of the Microsoft R, and I'm just going to talk about the differences. So I call this the Perl plot, so don't let the Perl deceive you. This is not to tell you that CRAN has less functionality. You can think of these circles as more performance circles, where you go up a circle, the performance increases in terms of the runtime and the amount of memory you can manage, and also parallelization purposes. So at the core of it all, there's CRAN. Because Microsoft doesn't really create their own R packages. They take whatever is existing out there, they take the latest cron, and then they migrate it over. And for that reason, there's generally a lag. For example, the latest image of the R version that Microsoft has, I'm going to show you that too, is an image of cron from September of 2017. So there is a sizable lag. You're not going to have access to libraries that come out today, but you're going to have access to them in a matter of months or so. So when we go up a circle from cron, we have the Microsoft R. It is more efficient, it is faster, but you can definitely see the speed improvement if you're making a lot of matrix operations. And since today we are talking about enhancements and also bindings into being able to accept raster objects, with things like matrix operations are really common to do with rasters, such as calculating convolutions on an image and so forth. So when you do anything related to matrix algebra or linear algebra, you're going to see an immediate increase in your performance, because the entire Microsoft R functionality is calling the MKL library in the background, which is a C++ library, so it's much faster. You can go up one more and then use the Microsoft R client. So now you can parallelize things on your machine. If you like to run things on parallel, if you have big jobs, you can do that. And you can go even up a circle and go to the Microsoft R server, where you can parallelize your jobs on a server. You can work at a massive scale with your data using R. And if you're wondering where the free stuff ends, it ends at the third circle. So when you want to use Microsoft R server, it's preferable that you have an Azure account, because then you really can have access to machines that are really crafted to work with the Microsoft R server. So why would you even think about using something like Microsoft R? Because it does seem like it is kind of at the hand of a company like Microsoft. Well, one of the advantages of it is, as I said, performance. And today's topic is our raster integration. So in the realm of rasters, just like with anything, data can get pretty big pretty fast. Today I'm going to talk about two specific types, and I'm going to show you a simple demo using mosaics. So mosaics data sets that we frequently consume in ArcGIS Pro and process are made up of different rasters. For example, on your left, you can see an example of a mosaic where you can have satellite images from different patches. If you want to process them as a single image, then you can put them in a mosaic, and then you can process them within this mosaic data structure. Another very frequent use of these rasters and also mosaics is time series analysis. You can have snapshots from a satellite, or you can have a model that progresses in time. So you will have images that are stacked on time. So with that increased dimension, the data gets pretty big, pretty fast. And you can handle that using a time series raster and a mosaic. So with working with these big data structures, if you have an R version such as Microsoft R, you can really harness the power, the computational power that is given to you. Because working on mosaics and time series rasters, when you have space and a time dimension, anything that you may want to run might take a long time, especially if you have very fine rasters. So the functionality that Margin show is applicable to reading a mosaic data set as well. A mosaic data set, as I said, just consists of different rasters. The only difference is we need to define a method and an operator. So what this means is when we have multiple rasters, it basically defines how they will be handled within the mosaic object. I know this sounds a little abstract now. I will show this in a demo, and you will see what I mean by it. So with these methods, you can define what type of method you want to integrate different rasters and what kind of operators. So if you're wondering what those are, we replicate functionality from ArcGIS Pro. So we give you all the functionality we have in the form that it exists. So for this mosaic data set, for example, when we look at it, we have overlapping rasters, and these different rasters that make up this mosaic data set are covered with these green rectangles. So just to give you the rasters that make up of this mosaic, I have this climate model that are performed on specific portions of the US. I have a model for the West, I have a central model, a central east model, and an eastern model. So I have 4 different rasters with some overlap, and I want to combine them into one. So I can use a raster object for that, where I can feed these 4 rasters into one object, which is a mosaic. But you see that these rasters have overlaps. So how are you going to deal with these overlaps? So this is where the functionality comes in for mosaics, where you can sort them. You can say that whichever raster was added in first, just put it to the top. Or you can do things like seam lines, which are smooth transitions between these images. So you aggregate these 4 overlapping images into one using that. And the method and the operators that you can use, as you saw in the ArcRaster functionality, are defined here. You can define them first, meaning whichever raster was added into the data set first should float to the top. Or you can use things like mean, where at every overlap, the 2 images will be averaged for the final raster, and so forth. So I'm just going to show you how this works out briefly using in this demo. Oops. Okay. So I have a mosaic object, the local temperature model. So this is my mosaic object that is made up of 4 overlapping rasters over United States. Yes? Oops, thank you. It's not good. Let's see. Ah, there it is. Yeah. So I have this mosaic data set that is made up of 4 rasters that are overlapping all over the United States. And I've merged them into one data structure, and this is a mosaic data structure. Here I can see the current snapshot of these 4 rasters, the way they're combined. I can see the footprint. The footprint is the extent of every separate raster that I use in this model, and the overall boundary, the boundary that this mosaic object covers. So I can read this mosaic object in that consists of 4 rasters, and I can do operations on these rasters on the fly within this mosaic data set. Just to show you what that means. So for this example, I'm going to be, instead of the RStudio, I'm going to be using Visual Studio. And I'm going to be using the Microsoft R Open, the Microsoft version of R. So the second you load it, the beginning looks exactly like the same, like CRAN. You will see one difference here. The snapshot is taken from, this is actually a newer version, so from 1st of January 2018. So as I said, there's a slight lag with cron, but they try to follow it pretty closely. So this is my R console, and everything works exactly like R. I just import my libraries, and I read my raster object, the one that you just saw. So once I open this object, I'm using ArcRaster to read this mosaic object. And the way I define the method, northwest, and the operator sum, is basically going to take all those 4 rasters, and whenever they're overlapping, they're going to sum over the values. So this may not be a good way to aggregate them, but this is one of the functionality that we provide to you. These on-the-fly calculations you can do on the rasters that make up of this mosaic data set. So let's combine these 4 rasters that make up that mosaic that way, and let's just plot them in R. So this is what it looks like. Not very surprising, very high values where there are overlaps. So let's try to do something a little bit better. And this is the beauty of the new functionality. You can do everything on the fly. I don't really need to go back and read the object again. I can just change the object on the fly. So for the same mosaic object that is consisting of 4 different rasters, this time whenever they have overlaps, I'm going to blend them. Hopefully this will give me a smoother picture. And it does. So now I've merged these 4 regional models that made up my mosaic with some overlap, and then I just merge them. So normally you will need to run a processing function over, and then in the old version you may need to export this and then read this back in. Now we don't have to do that anymore. Everything is on the fly. You can take all these raster components within a mosaic data set, and you can process them on the fly using the ArcRaster functionality. And after you're done, you can export this as a raster, which is what I did. And I'm going to show you a different pattern since we're talking about performance of writing things out. So this is a different pattern you can use, and all this code will be available to you. If you have a very big raster that you're trying to write, when you're using ArcWrite, you may run out of memory because you're trying to do everything in one go. You might be loading a huge matrix, and you may just trying to be writing a huge matrix in one go. So if you actually have a very fine raster, one pattern you can use is using the ArcRaster object, you can define an empty raster first, something that is just consisting of nulls, that doesn't have any data in it. And after you're done doing your analyzing your mosaic, you can write it out as a raster if you'd like to. And if you want to do that, you can just change the pixel block property of this null raster that you just defined. So now, here is you can do a trick where you can write this pixel block in chunks, meaning that you can write 50 rows at a time if you don't want to put the whole thing in memory. So this gives you that flexibility. You can really write things out in smaller chunks if you don't have the memory for it. And this pattern allows that, for you to do that. And after you're done, after you've filled your pixel blocks in your raster that you want to write out, you can just do a commit function, a write raster commit. Once you commit it, it'll just write it onto your disk, and you will have this big raster on your disk. And this is the end result of the raster that I wrote out. The null values are also filled in using R. So this is the end result that I have. So this is just to get your feet wet using mosaics. Another thing that I said that the data gets pretty big is when you have a time component. So I'm just going to show you a quick demo and a real-life application of how to do that. So this is a slightly different problem where we have a global climate model, meaning that at every month, the global climate is simulated using a numerical simulator. So I just stacked all these rasters into one multi-band raster. So when I look at these, every band is basically a snapshot of world temperature at a given month. So I just stacked everything into a multi-raster. So when you try to visualize this raster on its own, you can see the overall trends, but you're basically looking at an RGB value coming from month 1, month 2, and month 3. So this is not very meaningful, but this is one way to process your data, where you can store a time series raster this way. So I have the same thing from the global climate model for rain, where I have different profiles for rain that is coming in. So this is really hard to look at here, so I'm just going to move everything into R and perform my analysis that way. So I'm reading in the multi-band rasters, and when I plot the rasters, it plots everything band by band. So this is the rain profile from the global climate model. Band 1 corresponds to January, February, and so forth. You can see the intensity of rain in certain areas in the world in this time series raster, and this is an interesting way to process these. I do the same thing for the simulated temperature for the world. And these are pixel values, these are the intensity values that are simulated. This is an indicator for simulation, so I don't want the numbers to throw you off here. So once you have these rasters, the bridge gives you the capability to, if you're interested in the first 3 months of the year, using the ArcRaster object, you can only call for the first 3 bands. So this is one of the functionalities that lets you subset your data on the fly. So if you're just interested in the first 3 bands, you can do that, and you can just retrieve your first 3 bands. A very basic but very powerful functionality. And these global climate models are very coarse. So if you want to see how coarse they are, let's take a look at raster objects for them. Because when you just print your raster object, you will see detailed information about that raster. This is the ArcRaster type. You will see that it's a raster. You'll see the pixel type. And it's a 73 by 96 grid, which is pretty tiny. You can see the extent and geographic coordinates that it is projected to. So I want to use a different scale. I want to turn this small 73 by 96 to 1,000 by 1,000. And on the fly, ArcRaster can do that for you. It can resample it, and it can interpolate to a finer raster. So I'm going to do that, and this is the rain profile now plotted for 1,000 by 1,000 at a much finer scale. So what I'm interested to do here is detecting tropical climate using this global climate model. Because if I can do that, these global climate models are simulated into the future. So I can see if the tropical areas are going to change as climate changes, because these models are calibrated with increasing carbon dioxide in the atmosphere. So to do that, I'm going to use a pixel-based method. What I'm going to do is, in these images that you see of the rain, I'm going to detect where the main rain body is, where it's raining, because the contiguity is important. If you have a small patch of rain here and there, it doesn't classify as a tropical. It may not classify as a tropical climate, but you need wider areas which receives consistent rain. And to do that, I'm going to be using a thresholding method, using an image library that is within Python, and the function itself is called threshold. So I'm going to take the rain profile, and I'm going to threshold it. Now I'm extracting bodies, and the whites here correspond to areas in the world that receive higher rainfall. So I can just detect these objects from a fuzzy image. So this is just an image operator. And I can do the same thing for temperature. Detect areas where it is consistently hot, and not surprisingly, just around the equator. So detect these bodies, and I need to intersect them, because the definition, the definition I'm going to use is an area that is consistently hot and consistently rainy. So I'm going to take an intersection of these two using constructive solid geometry, which is again very easy to do in R. And then I'm just going to write my results out to ArcGIS Pro using the same pattern I showed you before, using a commit. So let's take a look at the results. So these are the parts of the world where it's consistently raining, or I can detect a body of rain throughout the space. I can do the same thing for temperature. Again, what is marked here are the areas that are consistently hot, and again, is a contiguous body. And this is what their intersection looks like that I find from R. And I can further process these in Pro using the Raster to polygon tool, and I can actually extract the polygons that correspond to these areas of high rain and high temperature. And I do that for the rain. So these are the areas that receive a lot of rain, which makes a lot of sense. We have it over South America, Central Africa, over Australia and Polynesia. And these are the high temperature polygons. And these are the intersections where it's found to be, where those two are intersecting, meaning a tropical climate. So this is a very simple workflow that enables you to do something like that. And when you compare the result, for a very simple workflow like that, the result is actually not bad. You can capture parts of Brazil, Central Africa, Australia, and also southern part of India. So this is just a sample use. One interesting thing here is I used an image extraction operator, meaning that I was processing this matrix, which was a raster, and I ran a function on it. So what is the difference if you use Microsoft R versus cron? As you see, I've resampled my raster to 1,000 by 1,000 to do this. And I increased this resampling size, and I did a very simple convolution operator that is multiplying the raster with itself. So you can just think of this as a matrix multiplication. So these are the speed differences. The green line is cron, and the orange line is Microsoft R. So when you have small rasters, up to 2,000 by 2,000, you don't really see a big difference in these image operators that use matrix multiplication. But there's a threshold when your data gets bigger and bigger, when your raster gets finer and finer, there's a big speed difference. The biggest raster I tried was 10,000 by 10,000. And when I took a convolution operator on it, using cron, using the same function, it took me about 700 seconds. Whereas with Microsoft version, it took me about 0.14 seconds to do that. So there was a huge speed difference between the two. So using Microsoft R makes sense, especially if you're really interested in this new functionality with rasters, and if you have big rasters, if you want big processing power, it does really make sense to use something as powerful as Microsoft R. And finally, I just want to talk about this biggest circle I showed you, the R server. You can integrate things into an R server too. And that's going to be, I'm just going to quickly show you how to do that. So when you're in the R server environment, everything is exactly the same. The first step you need to take is, again, link your R version of R server to ArcGIS binding. So this may sound very trivial to you, but if you've worked with servers before, installing a library on a server can be a hassle. It can be really painful. This seemingly simple tool actually makes that quite easy as well, because I can just point to R server and I can install the ArcGIS binding package directly on the server, meaning that all the nodes I'm going to create on the server is going to have access to this package, which is pretty powerful, and it will save you a lot of time. So I'm going to be using a very simple operator. So what I'm going to do here is I'm going to detect where trees are in a raster. And the way it is done is just very simple. When we have a spectral raster that consists of 8 bands that are different color bands, such as red, green, blue, infrared, so on and so forth, you just extract specific bands in this, specific spectrum in this rasters, and then you just difference them and then divide them by the sum. So it's a very simple operator. It's as simple as it gets. So before doing anything on the server, I'm just going to do this whole thing on a single machine. Everything is exactly the same, with one difference. If you see at the corner now, I'm using an R server. I can still use the console. It does have R installed on it, but R server allows me to distribute my jobs to cores that I create. And I define this very simple function, ndvi create. This basically defines the function I just told you about, the difference between two bands divided by, let me enlarge that, the difference between two bands over the summation of the two bands. So a very simple function. And I first run this on my machine. This is a satellite image over Southern California. So this is what I observe in R. I did not put a color scale just to show you where the satellite image is. And just to give you an idea of what I'm doing, I'm processing a satellite image. So this is on a single core. So now, here is the interesting part with R server. R server gives you the ability to define your own cores. So this is an administration tool where you can port R onto your server, and you can configure a server yourself. It's disappearing. So this is exactly what I did. I just configured the server, and for the purposes of this example, I have a remote computer living somewhere else that has access to R. Now I'm going to just send jobs off to the server, going to process it remotely, and then bring it back to my machine. You can see that this is very easy to scale up. If you have hundreds and thousands of these machines, you can break up a big job, send it off using R server, process, and then bring it back to your machine. And that is very powerful. So to do that, first I need to log into the server I created. And when you do that, R automatically asks you to log in. And once you've logged in, you need to define these things called APIs. So these are web services, meaning that the function I created is going to be published on a web node, and this computer is going to have access to this function. It's going to know what this function is. So the second I start sending data to this computer, it's going to know exactly what to do, and it's going to know exactly what to return back to me. So I define these functions, and I define these APIs. And I'm just going to print to see what they're all about. So here, it shows you basically the details of the web service you created. So this is a web service. You can see that it lives on a JSON file, which you can share with others if you want them to access to this. And it integrates seamlessly to Azure Machine Learning Framework as well, if you're using that. And I'm going to do two things here. So I created two APIs. The first one does a matrix operation. They do exactly the same thing. In one of them, I'm going to pass the entire raster onto the remote machine. I'm going to process it as a raster, and I'm going to get it back as a raster. In the second one, I'm going to send it pixel by pixel, and I'm going to get it back pixel by pixel. So they're doing exactly the same thing. It's just the transfer that is different. And I'm going to time these so that we can see what the timing is like. It generally takes about a minute. Just to tell you how this can be useful is, especially with things like rasters, as I said, data gets pretty big, especially in time dimension and space dimension. You can create your jobs into smaller portions, and you can extend this to remote machines as well. So you can run everything on a server. And a job that takes you hours, it can just take you a matter of seconds to complete. So as it's still working, I will show off one of the important things as well as it's doing the calculations. You can export these web services you created using the Swagger functionality. So what it does is it takes the APIs that you created on this remote node, and that it exports it as a JSON file. So this may sound like a lot of lingo. What this means is your entire web service that you created is now contained in a file, meaning that if you pass this file on to someone in your company, they can literally just start sending jobs to this, and they can basically run your function remotely without you having to do anything with it. So you can encapsulate a huge R functionality remotely, and you can easily share it using this JSON file. So this is one of the capabilities that Microsoft Server brings. Okay, so both of my remote jobs are completed. I did all these jobs in a remote machine, and I got them back. I first did a full matrix solution. it took me more than a minute. The second one is misleading because this is exactly the same thing, because it's a typo. I did the operations pixel by pixel. I did not send the whole matrix to the remote machine. I sent it pixel by pixel. I got the exact same image back, which is the one on the right here, kind of small. But it took a much smaller amount of time because I didn't have to transfer big chunks of data at a time. I just transferred small bits of data at a time. And now I picked that the second one, where I do things element by element, is faster. I export it to a Swagger file, or using Swagger, I export it to a JSON file that I can share with somebody else, like here. And after you're done, you just need to delete the services so that your server doesn't get gunked up with a million web jobs. And this is basically the additional functionality that you get when you switch to Microsoft R, this immense scale. So with that, all the resources that Margin has pointed to, you can see at the end slides here. And yeah, I think that is it.
Yeah, hopefully a nice peek at some raster functionality, working with big data, and certainly we have some new Learn lessons coming out. Oren has done a really awesome one with some machine learning techniques that he uses Python for, and I've also am working on one to show off the raster support. So there's some cool stuff to look forward to with regards to that. But if you have questions, feel free to come up. If not, have a good rest of your conference. We'll both be at the island for this afternoon, and I'll be there for sure tomorrow. So, yeah.
This is the website that Margin is mentioning. So we already have the first R lesson here that Margin has created. It's a very good one. I highly recommend it. Analyzing crime statistics using statistics and R-ArcGIS Bridge. So this basically shows you how to use R, and I think Margin is a new one coming out as well.
Yeah. Cool.
Thank you.
Thanks.